Hi Ellie. We were going to discuss radian measure. Alright, so let's do that. Okay, so there are two ways of measuring an angle. One is the usual measure, degrees, and what's so special about those units? Well, that's not too good. What's so special about degrees? Well, nothing really, only the reason why we use 360 to represent a full circle is because there are approximately 360 days in a year, and the Earth goes around in a full circle in 360 days. So there's nothing really special about that number. All right. There's another way of measuring angles, and that's called radian measure. And let me show you an example of that. Radian measure is based on a circle with radius 1. So let's say this is a circle with radius 1. Okay, so that's 1. The circumference of this circle is 2 pi r. 2 pi r, and r in this case is 1, so that would be 2 pi. 2 pi for the circumference. Alright, so a straight angle, let's say, here we have a straight angle all the way around. That in radians, that would be the length that it cuts off in the circle. That would be half the circle. Alright, so 180 degrees is straight angle. In radians, it's half the length of the circle, which is pi, and 360 degrees is the full length of the circle. That's 2 pi. So these are radian measures. Pi is a radian measure, 2 pi. What about a 90-degree angle? Well, there's a 90-degree angle, and it cuts off a quarter of the circle. So that would be half pi divided by 2, pi over 2. And you can go on like this. You can go on like this. Let's say 45 degrees is half of pi over 2, so that would be pi over 4. And let's say 60 degrees, that's a third of the circle, so that's, no, wait a second. No, 60 degrees, 120 degrees is a third of a circle. 60 degrees is 1/6 of a circle. So that's 2 pi over 6, or pi over 3. And what about, well, 30 degrees? That's half of pi over 3, so that's pi over 6. Alright, so in general we have the following way of converting, like this, you see, right here. If we have degrees, we just multiply by pi over 180. And it's easy to remember this because pi is 180 degrees in radians, so it's sort of like multiplying by 1, pi over 180. Both of them, they're both equal. Alright, so that's how we get the radian measure of an angle. So for example, let's say, let's just pick, let's say 18 degrees. That's equal in radians, 18 times pi over 180, and reduce that, we get pi over 10. Alright. And to go the other way, so that's how we convert from, here I have it over here, that's how we convert from degrees to radians. And you multiply by the reciprocal. To convert from radians to degrees, you multiply by 180 over pi. Alright, so for example, let's say we want to convert, let's say 2 pi over 5 to degrees. Alright, so you just multiply. 2 pi over 5 times 180 over pi. And it's easy to remember because really, usually radian measure usually has a pi in it, although it doesn't have to. But when we multiply by 180 over pi, the pi is always canceled. All right, so here we have 2 times 180 over 5. Okay, so that's equal to dividing the 180 divided by 5, 2 times 34, or 68 degrees. Okay, so finally we're up to the last bit of the sheet. Let me do that. All right, which is the graphs of some of the trig functions. There they are. And there's probably more that you have to know, but for now, let's look at the graph of y equals sine x. Well, y equals sine x is a periodic function. The one period is 360 degrees, or 2 pi, and it's basically a wave that repeats itself, goes on forever in both directions. And let me just point out that from the graph there are some values of the quadrant angles that you can just read off. Like here we see that sine 0 is 0, sine of 90 is up here at 1, and sine of 180 is 0, sine of 270 is down here at -1, and sine of 360 is 0. So that's another way of remembering the quadrant angles, the sine values of quadrant angles. All right, that we had this method before here, where we could find the sine and cosine values of quadrant angles by looking at the coordinates of these 4 points. This was cos 0, sine 0, cos 90, sine 90, okay, etc. All right, so you can do that, or you can remember the quadrant angles by just, if you know the graph of y equals sine x. For y equals cosine x, let's see, we have cos 0 is 1, cos 90 is 0, cos 180 is -1, etc. Now, look at tangent x for a minute. All right, look at y equal tangent x. Now, remember that tangent x is equal to remember that tan x. Whoops. Let me write that here. Remember tan x, or tan theta, if you like, is equal to sine theta over cos theta. So whenever cosine of theta is 0, we have a vertical asymptote when the denominator is 0. When is cos, let's see, at 0, no, sorry, at 90 degrees. All right, that's here, 90 degrees, vertical asymptote, 270 degrees, vertical asymptote, and this continues down like this at -90 degrees, also vertical asymptote. All right, so that's why tangent has these vertical asymptotes, and tangent is also periodic, it repeats itself, and the period is not 360, the period is 180. You see, from -90 to 90, that's a length of 180. Okay. All right, that's it for now. I'm going to send you this video. All right, I'll talk to you soon.